Access, May 10, 2024. Creating Accessible Science Capital for Individuals with Disabilities in Science Museums. Gabriela Sehnem Heck.
Thank you very much, Anna. I hope my internet is stable. I am from Brazil, and we are facing this several flooding in our country, in my city, actually. And I didn't have internet for a while. Now I have, but I opted for recording my presentation so I can show you my work. So I will let the video present. I have my audio description and everything about me. You can see there. But I would just like to thank you for this opportunity. I really follow the work from Access. So it's really a great opportunity to be here sharing my work. Thank you.
Gabriela, thank you so much for being here, and our thoughts are with you and your community. I hope everyone is staying safe, and really appreciate you, all that you've done to still join us here today. So thank you for being here, and we'll go ahead and share your video, and then afterwards, Gabriela will be available for any questions. Thank you.
Hello, my name is Gabriela Heck. I am a young white woman with blonde hair and eyebrows. And my hair is medium-length, straight, and loose. I'm wearing a white polka dot shirt against a blue background. My slides have a white background with information written in black letters, and I will be using some illustrative figures throughout the presentation. I am a PhD student in education at Pontifical Catholic University of Rio Grande do Sul, PUC-RS, in the south of Brazil. And I received a scholarship from the Coordination for the Improvement of Higher Education Personnel, CAPES. I'll be presenting the work Creating Accessible Science Capital for Individuals with Disabilities in Science Museums. This presentation is being recorded because I live in the south of Brazil, in Porto Alegre, a city that has been affected by severe flooding since last Friday. And due to this situation, I have been without internet for days, so I opted to make this recording. So there is a lack of interest among young people in STEM jobs after compulsory schooling. Among those who choose to pursue careers in these fields, they are often from a very restricted group: white, middle upper class, and male individuals. As a consequence, various sectors of society are facing significant skill gaps in STEM-related areas due to the lack of qualified candidates, which compromise the scientific and technological development processes of countries and has a negative impact on economy. In light of this, a group of researchers from UK, led by Professor Louis Archer, conducted a longitudinal study called Aspires, aimed to understand the factors influencing young people to aspire to compromise the identify, among many other aspects, that the attitudes towards science develop in school and within the family, as well as the young person's self-concept of science, which means how they feel about science, it strongly influences the science's aspirations. And also they identify some key dimensions in understanding young people's aspiration, such as scientific literacy, attitudes towards science, knowledge about the transferability of science qualification, science-related practice, and social capital related to science. Based on these factors identified in the Aspires project, the authors grouped these characteristics into a type of stock, a kind of capital, related to science, which they termed science capital, as an extension of the theory of the sociologist Pierre Bourdieu. Science capital is defined as a device capable of grouping different types of capital, such as economic, social, and cultural, that are specifically related to science. And it can be thought as a bag or a hold-all, where all the knowledge, attitudes, experiences, and resources related to science acquired throughout life are carried. Is it divided into 4 pockets? What do you know about science? How do you think about science? what to do with that scientific knowledge, and who you know in this field of science. They say everybody has a different amount of science capital, and this affects whether people feel like, yes, science is for me, or no. And the Aspires project showed that the more science capital a child had, more chances to follow STEM subjects. And science capital also can be used as a theoretical lens to understand the patterns of scientific aspirations and to identify potential causes of inequality in STEM participation in order to promote equity in this field, which is one of the main areas of growth and the main in the global economy. But they identify these inequities basically in three main situations: gender issues, racial and ethnic issues, and also socioeconomic issues. However, there is another segment of the global population that is still not being represented in STEM field, that is people with disabilities. Those people are almost always in a worse situation than people without disabilities, with, on average, less likelihood of attending school, completely primary or secondary education, continuing their studies at higher education levels, and being less likely to possess basic literacy skills. And the reason for the lack of participation of people with disability in careers in STEM fields are generally related to some aspects, such as the high cost of accessible accommodations, the inaccessibility of physical spaces related to science, the lack of encouragement to pursue careers in STEM, difficulty accessing financial assistance, limited understanding by employers and peers of the importance of presence of people with disability in STEM careers, the lack of representation models, discouraging attitudes from family members and colleagues, between many others. And barriers to inclusion go beyond the lack of access to accommodations. Culturally informed prejudice, stigma, and even doubts regarding disability contribute to underrepresentation and inequality. To promote aspirations in science and science capital, we can look through its 8 dimensions. So there is science literacy, science-related attitude and values, the knowledge about transferability of science, consumption of science-related media, participation in out-of-school activities, family science skills, knowledge, and qualifications, knowing people in a science-related job or role, and talking to others about science. But all these dimensions, they don't look deeply to accessibility issues. So we can identify inaccessibility in all these dimensions, such as instrumental barriers, communication, architectonic, methodological, attitudinal, programmatic barriers. And just to give some examples, how a deaf person can access the science-related media if this content is not available in sign language or doesn't have closed captions, or it doesn't have a audio description for blind people, and the magazines and books doesn't have braille. Or, for example, participation in out-of-school activities. If the places and the museums doesn't have physical accessibility, people can enter literally the museum. And even going inside, sometimes the content is not accessible, is not available in sign language with closed captions and with other accessibility resources. Knowing people in science-related job, if you don't have representation of people with disability in this job, it doesn't matter if you know people in this job, you still don't feel that this place is for you. And talking about others with science, usually people don't know sign language, at least here in Brazil. So it's really hard to a deaf person, for example, speak with other people about science, or even with scientists, other scientists. So there is many other barriers. I only quoted some of them. But in this scenario, museums are recognized as spaces for engagement with science, inspiration, and inclusion, especially when they provide accessibility features, such as sign language, audio description, tactile flooring, ramps, elevators, noise-canceling headphones, braille, among others. And with that in mind, My PhD thesis aims to understand how science museums can help improve science capital of people with disability. I'm currently in my final year of PhD studies, and to develop this thesis, I conducted interview with two groups of people with disability, blind individuals and deaf individuals. With this group, I conducted a guided tour at my university museum, especially in an exhibition about climate change, and explored the knowledge of this topic before and after the activity, as well as the potential of accessibility resources in engaging with the exhibition. I conducted some interviews and surveys and assessed the Science Capital Index before and after the activity. Currently, I am analyzing this data. But preliminarily, from the analysis, I can show you some of the results that I have been identified. So identify 4 categories of analysis, namely science literacy, exclusion in museums, communication and access to content, and attitude, values, and dispositions related to science, all of which are intersected by accessibility. And in each category, several questions were discussed. For example, in science literacy, we talk about a lot of causes of climate changes, the consequences of climate changes, and ways of remediation. In the category in exclusion in museums, we talked about some dimensions, for example, technological, attitudinal, programmatic, and institutional, sensory, and science-related behaviors and practices. In communication and access to content, we talk about resources that are sound and tactile, visual resources, and also disclosure of accessibility resources. And in the category attitude, values, and dispositions related to science, I identify some discussions about scientific career and scientific identity. Additionally, during my PhD studies, I was able to implement some accessibility actions at the university museum, such as the creation of a sensory bag with a lot of sensory toys, the headsets for noise canceling. Also, we developed a sensory map with the places that are more and less have more or less sounds and that can be more calming and more stressful. We developed the autism-friendly opening, and we have a sensory room in these openings, a place that people can stay and stay quiet and auto-regulate itself. We developed our visual story with all the ways to get into the museum, what you will find inside the museum. And we are finishing out the link for the website that have all the accessibility features. So you can find everything in the website right now, but we are still developing it. So there are more resources being developed. We are also doing a tactile tour. So we are identifying places in the museums where you can touch that will not have problems to touch. So we are still working on this and step by step making it more accessible. Here I highlight some of the references I use in the presentation, some of the papers that I use in the slides. And this is the current results that I have, but as I mentioned, my thesis is still on progress. So if you want to follow my results, you can check on my Instagram account. It's called Science Capital Brazil, where I translate some materials from Science Capital team and also publish some of my results on the thesis. And also you can access my ResearchGate is the place where I put major part of my work. So it's researchgate.net/profile/Gabriela-Heck. And thank you very much for this opportunity.
Sci Access. Learn more at www.sciaccess.org.